Thank you, Erika. So privacy on blockchains is solved. Zero knowledge proofs, multi-party computation, and fully homomorphic encryption gives us privacy. Most of you in the room would agree with me here, or at least agree that if we are not there yet, we'll be soon there. The dominant story here is that we just need a bit of better tooling, a bit of better performance, a bit of better developer experience. And we need policymakers to align on privacy with us, that they don't see this as a threat, but as an opportunity. Today, and if we solve everything of this, privacy adoption should follow. Today, I want to challenge this framing. Not because better policy and better tooling don't matter, they do, but because even if we solve all of this, something still doesn't work. And the reason for that has little to do with cryptography. It's more about how the state that we are creating on blockchains. Most people, when they talk about privacy on blockchains and private state, they mean something like private state per user. So it's you own the state yourself, you're the single owner. A classical example is CK passport, or proving that you're over 18. Your age is your data. So you can prove it, and you don't need any other input, and you can share this property or prove this property without having to rely on anybody else. This is a very clean model. It is like you are the single owner of the data and the state. And there are little trust assumptions, very minimal trust assumptions. And this works great for a whole class of applications. Things start to change once an application has to reason about more than one user at a time. And think about, for example, matching to users, or comparing two trades, or checking uniqueness in a system. So any constraint that goes beyond two users, really, there is a struggle with this private per user state, and it stops being enough. If we have a state across multiple users, it stops working. And this isn't just about the cryptography fails, it's because we're moving to a different state model. And so far, we don't have a good language to talk about this. What we really want is a private state, but not owned by a single user. I call this private shared state. Imagine a system that wants to check if somebody is already registered, but this time without knowing who they are or who else is in the system. Naturally, you have to have the information of all the users using that system, but no single user owns this private state. This is very tricky. And once we are in this new state model, there is a question. We rely on values in crypto, permissionless, that seem to be very difficult for this state. So let me back up here a bit. Permissionless in the sense of deploying arbitrary smart contract, arbitrary logic to a state. This is what most people in crypto rely on, and what fueled the growth in DeFi. You can build Lego bricks, and you do not have to ask which program you run on a blockchain. Now, what happens to private shared state, this new state which we need for privacy applications on chain if we allow permissionless deployment of smart contract? So this is really, can private shared state be permissionless? And you don't have to dig deep into the rabbit hole to figure out the cracks here. So if we would allow arbitrary, logic, with public state, one program would be to reveal everything. So you could just deploy a program that copies all the private shared state and posts it to some public place, and immediately renders this private shared state useless, as it's again a public state. And why did you even deploy all these complex technologies to create this private shared state if a simple program can break it? Now, once you realize that arbitrary logic is off the table, the question that arises is, who can decide now? Like, who decides which logic is allowed to run on this state? And so let's walk through this from first an app perspective, like saying like there's an app on the private shared state network, and that is controlled by a company, for example. Now, the company can deploy whatever smart contract they want, and so one of them is, of course, like copying all the data into their central database, giving the user no technical privacy guarantees, so they can also just rely on like the written word of the company that then don't misuse the data. No need to use some fancy cryptography here. Maybe it looks like, okay, maybe the guardian of this whole thing should be the private shared state network. They probably are some experts in privacy, cryptography, distributed systems, governance, whatever. So maybe they should guard which logic we allow on the network to be computed or not. Sounds nice, but and like if there are like 2 free applications, they can probably do this. But imagine this thing scales to 10, 100, thousands of applications. They may have like expertise in privacy and cryptography and all that stuff, but they are not like domain experts in the application. They do not know the context of the application that is like requesting maybe a new feature, a new computation on the private shared state. And as we know, like privacy is so context specific, you cannot even define it in computer science terms. It's just like privacy only makes sense in terms of a context. So one function could be leaking a lot of privacy, and the same function in another context could like do nothing. So maybe all things become easier if we say like the app is like not actually a centralized company, but is like a protocol. And we have some decentralization here, and we give the governance to the protocol. Now we know all like that protocol governance is already a bit messy in the public case. Now think about how would like people argue if like their own personal data would be involved there. Would this be like a model that really scales? Lastly, we could think about like a very democratic process, like giving the users the right for every function that is deployed on their data to say like yes, no, or whatever, and opt out. This like a simple majority rule would also be very dangerous, as you could see that the majority could harm a minority because they say like, okay, I don't have to lose that much with this private shared state, but I know these guys have, and so let's just vote on the program to reveal everything. They are worse off than I am, so it's like a win for me. Once you walk through this, you see there is no really neutral choice. Like as we have in public state, it's very easy to say, okay, we allow any program to exist and modify the public state because like there's nothing you could leak or like destroy or whatever. But it completely changes with private shared state. It forces some responsibility, and it forces us to think like who should take this responsibility and who should make the decision under which criteria. So far, like in cryptography and privacy tech and so on, we have mostly focused on like making things faster, making things more privacy preserving, making things more secure. These were the clean parts, I call. And this was for maybe the last 10 years. It's very measurable, and we also needed it to get to a state where we can start to deploy this system in the real world. But now that we are starting to deploy this in the real world, those questions will be asked, and there are like more questions than answers. So I think the one takeaway from this talk is like that we have to, as a privacy community, build us in the privacy community and beyond, because like I think there's a lot of knowledge in the blockchain community that could be transferred to this. We have to think about who is responsible, who gets to decide something, who is accountable. And that's not really a technical question. Like there's no clean technical solution or like this is like the optimum we can reach. It's really a discussion we have to have. And if we want to have true privacy on blockchains, we now have to get our hands dirty. Thank you.
Have some questions for Lukas? Love the presentation, by the way. Question? Oh, Ilya?
Wait, please. I mean, speaking of the responsibilities, do you feel the kind of what is the split of responsibility around, you know, malicious behavior, money laundering for different actors in the system, right? Like the operators of this private shared state, the deployers of the code, the operators of the front ends, etc. Like again, this is opinion. What's your opinion between kind of distribution of responsibility across these parties?
Yeah, I think, like I said, like more questions than answers. So far, like this talk was mostly focused on, I would say, like front-loaded, like the app and like the app developer that has probably the responsibility because it's direct access to the users. I think the validators themselves, or like the network operators, do not have a lot of responsibility here. I think they're mostly like do not know what's going on, like they execute just the code. Of course, like if you think about a network like a private shared state network, it could be that they have also governance. Then they have responsibilities. A lot of them, I think, don't want it. Like a lot of the classical validators do not want to have this responsibility, and we don't even have to go to money laundering. It's just about like, okay, I collected this data for identity purposes. Now this app comes and says like, I want to do some financial stuff with the data as well. And it's like, okay, is this what the user wanted or not? And I think it's very hard for the network to decide for each application, like, is this something they want to do or not? So far, most natural, it feels like the one that has direct user interaction needs to have most responsibility. At least that's like Web 2 style of like how we think that, like if you go to GDPR or any data protection law, it's mostly you have a data controller concept, which gets very blurred in blockchains. Like who is the data controller in a decentralized protocol? And yeah, I haven't seen like really people talking too much about this. I think it will be much more important from now on.
Well, especially because you have to control, right? So you can have two applications calling each other, and even if each application is responsible for their stuff, who's responsible for this interlink?
Exactly. Like, is the one calling, if A calling B, is B responsible to say like, these are the function you're allowed to call, and this how often you call it or whatever? Or is it like A that is like, okay, it's combining this with their user data, so there's still some responsibility left, and as protocol A, I don't want you to call protocol B, which in like public state doesn't make sense, those questions.
Yeah.
Hi, thank you for your presentation. More like a personal question, but what inspired you to start TACEO? And also, as a guy from Vienna, I know you guys are born in Graz. What was your biggest learning on the path from like building a small startup in Graz in Austria, like a country not many people even know of, to like now a global stage?
Yeah, like I'm very proud. I'm born in Salzburg, studied in Graz, so distinction here. But like this is nitpicking on Austria. We were like, there's this famous cryptography group that started already 20 years ago in Graz, and like that's where like the folks of TACEO found together, and we became friends. And during COVID, like the government asked us to deploy or develop a privacy-preserving application to combine mobility data with infectious disease data. And it was a nice paper and so on, and we want to follow up, and we're really like talking to like implementing it. But you can imagine, like as a research group, especially in Austria, like you're not set up like for execution, like beyond the paper. And so it really got stalled, and it was like we could see that the performance from those technologies mentioned are like for at least some use cases, this was like 4 or 5 years ago, in a range where you can deploy it on a large scale. And it was very like sad to see us, like we were such big fans of privacy and that the tech we're building, that the only thing we couldn't follow on was because like we were still in the lab and not set up in the right way. And that's where we like, it took us 1 year. And yeah, things are definitely not easier in Austria to make this happen. From engineering-wise, like we have a good support from our home university, like one of the best cryptographers coming from there. But everything around company building is like much harder if I look to my friends in the US.
Thank you for the question. Any other questions before we move on? All right. Good. Thank you for Lukas, and
Thank
give a big round of applause for Lukas.
Thank you.